Good day, everyone. My name is Gabriel Amaizu, a research assistant at the ICT Convergence Research Center, Kumoh National University here in Gumiko, South Korea. Having had a brief introduction to what Metaverse is as a concept and a topic, I will be taking us on its applicability to manufacturing. We're going to be looking at ways in which the various technologies we've heard from this previous speaker has aided us to envision a world where Metaverse will be used in manufacturing. So this is our content for today. First of all, we'll have a brief overview of what manufacturing is. Then we'll look at manufacturing amidst a pandemic like COVID-19, how it affected manufacturing and what we can draw from it. Then the journey so far will take us through the various elements of Metaverse, how they've been applied to manufacturing. Then I will show you a case study of one of the big car manufacturing industry and the tech giants, BMW and NVIDIA, coming together to create what they call the factory of the future. Then we'll draw our conclusions from there. So what is manufacturing? Manufacturing is simply fabrication or assembly of components into finished products on a very large scale. Now, manufacturing is in so many industries. We can find it in the automobile industry, the aviation industry, in chemical industry, and heavy machinery industries, because all these are kind of subset of manufacturing industries. Manufacturing industry didn't just start today. We've gone through it has gone through so many industrial revolution. The first industrial revolution, which was the birth of mechanization. We had our steam plants and all that in 1784. Then the second industrial revolution was when electrification was a thing. That was when we started having mass production, we started having assembly lines. Automation never came until the third industrial revolution. Then we started having automated factories and automated industries and things like that. Then we have our computers and electronics. That was in 1969. Then right now we are currently in the industrial, the I 4.0 era, which is the era of digitization, or where we're moving towards. So this has been aided by things like cyber physical system and the Internet of Things, the networks. So before we can go further, we have to know what the concept of smart manufacturing is. Smart manufacturing is smart manufacturing is any manufacturing method that improves its performance with integrated and intelligent use of processes and resources. Now, there has been so many evolution. Now, we can look at the evolution from conventional to smart manufacturing as in the initial stage, there was a huge emphasis on manpower. But gradually, while the emphasis on manpower in manufacturing is going down, the emphasis on knowledge and experience in manufacturing comes up. So what we can say is, in the initial industrial revolutions, we had humans working as machines, but now we are now having machines learning to work as humans. Now, there have been some driving factors to this. We have the industrial IoT, we have big data, we have cloud computing, and we have AI. All these technologies have tended to drive us from a human-focused manufacturing into a machine-focused manufacturing, where machine learn to work as humans. So why do we need smart manufacturing? For us to answer this question, we have to see the difference between conventional and smart manufacturing. Conventional can be traditional manufacturing. So in smart manufacturing, there's diverse resources. Now, diverse resources is just simply that in smart manufacturing, it is technically easy for you to switch between production lines. Like you can produce different products at the same time using different resources. But in conventional, it's all about mass production. Remember the industry 1.0 we talked about. It's all about mass production. We want to produce this computer chip. We produce only this computer chip in a large quantity. We cannot change our factory to produce computer chip and probably produce a mouse or a keyboard or something at the same time. So smart manufacturing has deep convergence, meaning that each parts are related to each other. There is communication. When there is a breakdown here, the other one takes up. But in conventional manufacturing, the layers are really separated. That is, I would say the right hand doesn't know what the left hand is doing. In smart manufacturing, things are self-organized. We have control is split among various resources. So one of the basic example of this is, for example, you have this production line, and along the way something gets spoiled. a smart manufacturing can be able to correct itself, but an independent, but a conventional manufacturing has to be shut down and the correction done manually. Then smart manufacturing mixes of big data because it's interconnected with everything. The factory is connected. But in conventional manufacturing, we have isolated information. We have independent control. Each system is controlled independently. There's no, yeah. Then big data, isolated information. Then dynamic routing. Dynamic routing is there should be routes linked that can easily enable us to switch from one production line to the other. But conventional manufacturing, through the mass production route that is taken, the routing is fixed. For you to change any production line, you have to stop everything totally and redraw the line of production. So there are some benefits of smart manufacturing. It reduces costs, it enhances productivity. Data is automated, things can be done on their own without the factory manager being there some of the times. Then there's worker safety, like since we bring in more of robots and more of intelligence into the work, we can easily detect as incidents in a factory. And of course, we can detect defects and improve quality. Now we'll look at COVID during manufacturing during COVID. So during COVID, the pandemic affected three key things: production, demand, and supply chains. And these three things are the key that underpins what a successful production or a successful manufacturing line should be. There has to be adequate enough production, there has to be adequate enough demand, and the supply chain has to be robust. Earlier last year, we did a survey on this effect on pandemic by looking at some factory staffs in about 6 different countries, and they all came up with a simple answer each time, that a manufacturing that is immune to pandemic has to be fully digitalized. That's why I told you we're now moving from smart factory to digital factories. We are moving from the smart era to the digital era where everything is digitalized. Now, for us to have an adequate digital factory, there are 2 things that we need: a digital production line and a digital supply chain. For a digital production line has 3 things that it brings together: the business, the design, and the operation of the organization. Before now, these things are seen as different aspects, like the business is different, the design is different, and operations is different. Probably we have different people heading them. But what the digital production line entails is we have to bring these 3 components together with the sole aim of improving the production process. Now, there are some features of this. Now, we have robots working hand in hand with humans in a safe and conducive environment. There's an ease of bringing in new design. You must have heard of additive manufacturing, where we don't have to go through a ton of hurdles for us to produce things. This is because we're using a digital production line. Then the factory managers. The factory managers are able to use most of these technologies because now we're now making them in UIs. We're now making good user interface, simplifying it, making it easy for factory workers to work from one place to another, holding a gadget or something and monitoring so many things. That is the aim. Then connectivity, we're connecting the factory floor to the cloud, and the cloud does all the processing, gets back the data. It is transparent and agile, then predictive rather than preventive. So there are some steps taken for us to go truly digital in terms of production line. First of all, we have to reinforce the physical deployment by bringing in sensors and actuators, such as, like I said, the robots in the factory. Then we have to set up a cluster in the cloud to analyze data, because when you have so many sensors on the factory floor, there's so many data, and the factory might not have enough power to process those data. So you set up a cluster in the cloud for this data to be processed. Now we move the historical production data and the current production data to the cloud. This data is now processed in the cloud, computed, and is sent back to the factory manager, where he can visualize the insights and the key performance indicators. This slide might be long, but I want to take out 3 things from this slide: predictive rather than preventive, the user interface, and the visualize. We'll be coming back to that in a bit. Then supply chain is just it's the advanced technologies that make stakeholders know where something is at a particular time, from the point of production to the delivery point. What this system does is it collects, analyze data, and provide timely, visible information to each partner in the chain. So, for example, I'll just give a brief example of this. A clothing store using a digital supply chain, just with a glance of the phone, can know how many, not the phone, any device anyway, a clothing store can easily tell how many, for example, blue jean they have in stock, how many jean is being produced by each manufacturer, and how many are coming on the way. Like, you can track all this, and this enables each of the stakeholder to know if there will be a delay in terms of delivery, or if there will be a delay from their part in terms of supply. So the other person can be able to factor in those details. So this is what a normal production line will look like. We have you start your production, the OEE, the operator, the operating equipment effectiveness. You check that, then you start production. Just give me a minute. Yeah, the OEE, you start production. You check all your equipments are working very well. They are all effective. Production starts or delivery starts. At some point, there's an outage, there's a breakdown. It could be anything. It could be power outage. It could be that the item you're supposed to supply, like in this case, got broken or something. Now, this guy here, who acts as a middleman or something, or a courier agency, is waiting for this thing to come on the 20th, but he has no information that is not coming on the 20th. Now, it takes up until 30 for this particular thing to arrive at his destination. That's like 10 days later. So at this stage, you don't even know if the delivery is going to be delayed. You don't know if the parts you ordered for is going to be the right part or not the right part. Finally, if it's not the right part, you have to fix it, figure out how to fix it. So all these things are done manually. But in an ideal world, in a digital production line, we don't have all this hassle. From the point of production till the point where you fix or you receive it, everything goes just as it's supposed to go. We'll come back to this slide later. I want to explain some of what is going on here in the following slide. So the journey so far, like you heard the previous speaker, he talked about XRO and the rest. So XRO is an all-embracing term. It covers virtual reality, augmented reality, and mixed reality. So yeah, VRO, ARO, MRO, and everything that lies in between them. So with XRO and Metaverse at large, we're trying to bridge the divide between the physical and the real world. We're trying to make them seamless, work hand in hand, like D1. So let's assume this is the real world. The real world is the physical environment around us. This place I am, wherever you are, is the real world. We have this technology I just mentioned about, and digital twin, which is the last one. We'll break them down one after the other. So VRO is, everything about VRO is completely digital. There's nothing physical in VRO. It's just a digital environment, a digital world. Now, in terms of manufacturing, there are a few things VRO can give to us. Now, these 4 cases you are seeing here are going to be constant all through the slides. I'll tell you what this can do and that cannot do. So in terms of the VRO, like I told you, everything is completely digital. There's nothing real. VRO has been used in product design and development. We have companies now, manufacturing companies, before doing any production, instead of getting a physical prototype, they have what we call digital prototype, and you can only see that with the VRO glasses. And when they conduct factory training, safety trainings, and the rest, you can put it in the digital world, and people just go there, put on the glasses, their VRO glass, and watch the trainings and what have you. So, but at the end of the day, with VRO, you are taking completely outside of the physical world, which brings us back to the accident that my colleague, the previous speaker, talked about. It takes you out of this world, and sometimes it could be addictive. Then came ARO. ARO, unlike VR, it's a real environment, but it's superimposed with the digital environment, with digital objects, like you've seen in those science fiction movies when things just display in the air, like just like that. That's what an AR does. A real environment, I'm here, but I can cast something on the air and see it. That's what an AR basically is. And in terms of manufacturing, of course, whatever the VR can do, the AR glasses can do them. Product design and development, like a digital prototype, you can use it to watch training videos, and you can factory, because the factory is a complicated place. There are some processes that you want these factory workers to go through that you cannot really allow them go through it in the physical world. Sometimes it exposes them to danger. But when you immerse them in this digital world, especially something like an AR, they can be able to go through those processes easily without you spending money on probably extra resources to train them. Like when I mean resources, I mean the raw materials or something, or experiencing an accident in the factory. Then, of course, with AR, there's communication and collaboration. You can see instance in terms of communication and collaboration, we're talking about when you use the this AR to get back data that is sent in from the cloud using digital twin. We'll get to that in a bit also. Then we had AR, VR. Now is the mixed reality. The mixed reality is, like the previous speaker said, it's VR, AR put together. So mixed reality is real environment, just like the augmented reality, superimposed with digital object. But in this case, you can interact with those objects. When I mean interact, you can actually touch them. You can turn them around. Just imagine you have a 3D projection of something in the air, and you can be able to, like, you know, that is what an MR does. It's a real environment, digital objects in the air that you can interact with. So in terms of the AR and MR, the devices are not really that different in terms of physical look, but they differ in terms of what do we call it? In terms of functionality. If you can notice, the AR does almost everything on this use case except maintenance and repair. Now, how does MR help with maintenance and repair? Now, with MR, it's easy now for factory workers to actually carry out this repair either remotely or on site, but hands-free. It's like you putting on a glass and you're watching a tutorial. While the tutorial is being displayed here, you're working on this. So your hands, you're not holding anything physical in the of course, holding a phone in the factory environment is not really ideal. So with MR, you get the advantage of hands-free and interacting with those particular objects that have been superimposed to your environment. So this is an example of what I'm saying. Like one of the mostly used MRO, or the only MRO now, is the Microsoft HoloLens. As you can see in this factory, they were using Microsoft HoloLens to determine some certain things. Now you can use it to monitor each of the production line, each machineries, to see which one is offline, which one is online, which one is having defects. We'll come to this in full later also. Then this was the tutorial I was telling you about. Like this lady now, she's carrying out a maintenance and she's watching a video. She's not been distracted. Her two hands are in use. She's using her two hands to do her job, but she's still getting all the virtual information that she can get, and it's not blocking anything. So still on the digital technologies, we're talking about digital twin. Digital twin is a virtual copy or a virtual copy of physical assets, products, or processes. Now, digital twin can be anything. It can be a virtual copy, or it can be a virtual copy of this building I am in. It can be a virtual copy of a factory, a virtual copy of just a supply line, a virtual copy of a product. It can be anything. But why digital twin is good, is taking us to the next revolution, is it enables us to do so much more. Because with digital twin and mixed reality, factories are now being able to create a replica of the entire process in a digital twin, connect sensors to their factory, and these sensors send these messages, send this data to the digital twin. So it's more like the factory manager is getting a real-time analysis of the factory at each time. Because when you're looking at the digital twin, you're seeing exactly what is going on in the factory. For example, you have sensors that are monitoring temperature, the air humidity or pressure, or the working of a machine. At a glance of, just as a glance of the eye, you can easily pinpoint what is wrong, where it's, what exactly is the problem, and it can easily be fixed without bringing about too much downtime. So there are things about this. The digital twin collects data. It analyzes, like I told you, the digital twin and there's the real world, but they are both connected because there are so many sensors on the real world object that you created, and those sensors are being sent to the cloud, which is connected to the digital twin. So you collect data, it is analyzed in the cloud. After that, you can now perform simulations and predictions. Now, simulations can be in any form. It could be, okay, this this production line that we've created, is it going to withstand this and that? Is it going to withstand that? So you try so many scenarios in the digital world. Now you're not spending money on building the entire production line before trying it out. You create in the digital world, then you run simulations to come up with the best solutions. Now, when you've come up with the best solution, now you can also make predictions about, there's what we call the remaining useful life. You can make predictions about the state of a machinery. You can make predictions about the rate of productions, and you can also visualize the inside. Yeah, exactly. So the farm manager can get a virtual view of everything that is going on in the factory using this digital twin. Then from getting the visual insight of everything, getting the key performance indicators, it can now make data-driven decisions, not just trial and error decisions like the smart factories or the conventional factories used to do. Data-driven decisions, then optimize what? Production. So I'll come back to this digital production line I told you about. You started production somewhere along the line because you're using the digital twin, and there's that section where we should talk about the predictions and simulation. The system has been able to predict that this particular robot, or this particular object, or this particular product, or this particular machine, at some point is going to have a problem. So what happens here is, because the factory manager already knows, there is a way he can incorporate automated, either automated repair or automated request for an external, for an additional part. So by the time this happens somewhere here, you already gotten the delivery, you've already fixed the product, and you have less of a downtime. So for this case study, I'll be walking you through a video of, like I told you, BMW and NVIDIA. I'll be walking you through a video of BMW and NVIDIA, where, just give me a minute if I can get this to play. Okay, I've seen it. So this is what BMW calls factory of the future. So it's a factory built by BMW and NVIDIA using the NVIDIA Omniverse. So what they actually did here was they've extended this to 3 of the factories as at early this year. What they did here was they created a digital copy of their factory. They ran millions of simulations. Now, when you're running simulations in the digital, in the digital world, you have the power of AI, which we'll be talking about probably by our tomorrow speaker. You have the power of AI, so you can run millions and millions of simulations. You don't have to be running them manually yourself. So what they did here was they ran so many simulations. As you can see, these 2 guys on your picture, they're planning a factory, and they are from 2 different places. So they are trying to make sure that the factory is both okay for both humans and robots, trying to make sure that objects are not placed too high or too low. But all these things they are doing it in from two different locations and in the virtual world. And it's like they're working hand in hand with each other. Now, after that, I will show you where they're using using AI and what they call the AI human. You can simulate human activities. Like I told you, you can simulate human activities to know the way objects in the factories are positioned. If they are positioned too high, too low, Does it cause back pain over a period of time and things like that? So at the end of the day, when all these simulations and all these assumptions is done in the digital world, they can now implement it in the physical world, and you find out that people work less, machines work more, because people are now working more intelligently, and machines are learning to work with them. So in conclusion, there has been a lot. There's a serious ongoing research on how this metaverse can be applied to manufacturing. But like we've already seen, the industry has been using from VR down to digital twin, which just became a thing a couple of years back. And the overall idea of this project is, with our partner universities, we should come up with a way whereby factory workers or factory managers can be able to access their factories virtually, create this kind of environment whereby repairs are automated, deliveries are automated, maintenance are automated, and it will be easy for them to work from the comfort of their home and still function as if they are at the plant itself. And these things can only be possible with more study into the metaverse, which include digital twin and MR especially. So while all these are still a bit away, or a bit not within reach, or not yet actualized, it is not that far within reach, because what digital twin and MRO has been doing has defied most logic, and we think it can play a critical role in metaverse, which is why so many of these companies, like you here tomorrow, most of the major car companies are going into it. So that will be all for my presentation for now. Thank you very much for your attention.